Hello, today I'll be doing alright. I'll be doing complex numbers. My Apple Pencil is not connected. I don't know why it's not connected. Oh, I think it works now. Yeah, it works now. Okay, today I'll be doing complex numbers, and some like questions on this. And first, do the first question. The question says the roots the roots of a polynomial z squared plus 2z plus 4 is denoted by alpha and beta. And for part of in beta, what is happening? Beta. And then for part A of the question, it wants to find what alpha and beta in polar form. So let's find alpha and beta like not in polar form first, right? So first we will try to find the roots of this. So basically z squared plus 2z plus 4 equals 0, and will be like z equals negative b plus minus square root b squared plus 4ac over 2a, and that will equal to negative 2 plus or minus, well, 2 squared is 4, so plus 4 times a is 1, c is 4, so 16. It'll be take, my bad. And then it'll be over 2a. 2a is just 2. So this is basically negative 12 plus or minus negative 12, 2. And that will equal to negative 2 plus or minus negative 3i. And 2 will come out as 12 is 4 times 3, and square root 4 is 2 over 2, and that equals to negative 1 plus or minus square root 3i. That means, and then we can set alpha as negative 1, let's say plus 3 square root 3, and beta is negative 1 take square root 3. Let's find the magnitude, right? Magnitude just equals negative 1 plus or minus square root 3. It doesn't really matter because we're squaring it. That's just square root 4, so that's just 2. So magnitude for both of them is 2, but we want to find the angle. So the angle for alpha will be tan, because the opposite will be like 1 square root 3 on the actual thing, right? So it'll be square root 3 over 1, which is 60, which is square root pi over 3. But that's not right, because look, negative 1, that means it's going this way. If it's going that way, that means 180 minus, so it's pi minus, so it's just 2 pi over 3. So, yeah, so should be, so then that means alpha is 2 cis 2 pi over 3. And beta, as we know, this is pi over 3. So then this should be in the third quadrant. So it's just pi plus pi over 3. So that's 4 pi over 3. That's it for part A. And part B, to show that a cubed is the same as beta cubed, I mean alpha cubed is the same as beta cubed. So alpha cubed is equal to 3 cis, inside we times 3, and that equals to 8 cis 2 pi. And beta equals same 8 cis 4 pi. And wait. We're proving we figured out this is the left hand side. Yeah, equals, and then that is what we want to get for b, right? So then we can just write that the alpha cube is literally just 8 cis. Well, because if you add 2 pi, it's the same exact angle, so you can write 4 pi. And then I can take the 3 out from cis, so it's 3 times 4 over 3 pi. And we can take the cube out of 8, so it's 2, and that's beta cubed, and what we should do that, which equals the right hand side. Yeah, it is the right hand side. That's right. And then for part C, also find the quadratic polynomial for which the roots a alpha plus beta and alpha take beta. So if the roots are alpha plus beta and alpha take beta, that just means that the polynomial should end up like x take alpha take beta, x take alpha plus beta equals 0. That's the polynomial. And we can sub alpha and beta in. So alpha in rectangular form is -1 plus square root 3i, which was what we set it as, and beta is take square root 3i. And that just means this becomes x. That's so cool. They updated the Apple eraser. Okay, we take -1 plus 1. I meant plus. Plus take. Actually, it would be easier if we don't expand it right now. If we expand it later, yeah? So this should just become x squared, take alpha x plus beta x, take alpha x plus alpha cubed plus, yep, and then take alpha beta, take beta x plus beta alpha, take beta cubed, I mean not cubed, squared. So this ends up with like that cancels out. Actually, no, it doesn't. This cancels out. And then plus beta alpha, take beta alpha. So take beta. So like that, we can wait. It's, yes, okay, that is right. So now we can literally just make it like, because this whole part can make it smaller, yeah? So it'll be easier if we do take, just be alpha. And that just equals, well, it should be x take plus 1, take square root 3i, square, take, so -1 take 3i square. So that equals x squared plus x take 3ix plus x plus 1 take square root 3i, take square root 3ix, take square root 3i, and plus will be take 3. And that should simply, this. That should make x squared. Oh wait. Oh wait, no, it's fine, yeah. It'll be take 2. We're making it way harder for ourselves. For myself, actually. So that's still just take a -1, that's 1. That's plus square root 3i plus square root 3i. Take 3. That should equal to x squared plus 2x. Take 2 square root 3ix. And that's plus 2. These two cancel out. And that'll be take 2, so plus 2. And these two will cancel out. Yep, so that end up with this thing as our quadratic polynomial. And that's it. I would say that's it. Yeah. We might be missing some. Wait a second. That's x, take 3, take 3, take. Oh. Because at least it'll be, this is still 2. This will be, because this is adding, so it's 2, and it'll be taking. So it'll be taking 4. My bad. Yeah. And then plus the other one, -2, it does cancel out. So that's it for the answer. And for part D, we want to find the exact value of A, not B, or A, B, which is the alternate or something. So it's basically like the imaginary part is signs flipped. We want to get the exact value of this. So this is basically just oh, it's not even A, it's alpha. This is basically just alpha because they're literally just inverses of each other. So it's just alpha plus beta. Which should just be alpha equals -1 plus minus square root 3i. This equals to 1 take 2 square root 3i take 3 plus 1 plus 2 square root 3i, and then it will be well, that's squared, so it's 3, but negative 3. So that just equals to, well, that's negative 2 with plus negative 2, so that's just negative 4, and these two will cancel out anyways. That's it for the first question. Now we'll do the second question. Second question says let W equals 2 cis theta and Z equals W plus 1 over W, and find Z in terms of theta. Z in terms of theta. So basically we just have to put W inside of Z. I'm not even close to my iPad. I don't know why it's doing that. Okay, 2 cis theta plus 2 cis theta, but this is basically just W negative 1. So negative 1. So that just becomes 2 cis theta plus 1 over 2 cis negative theta. And then we can expand this, right? So it's 2 cos theta plus I sine theta plus half cos theta plus I sine theta. Oh, negative, my bad. Negative, negative. And that basically equals 2 cos theta plus 2I sine theta plus, because cos negative theta is just cos theta, so it's plus a half cos theta. But the negative theta for sine is just negative sine, so it'll be negative a half I sine theta. Well, then we can combine them. This becomes 5 over 2 cos theta plus 3 over 2I sine theta. And that should be fine in terms of the, that's it for that question, I think. Yep, it is. And then for that's part A, and then we want to find part B. Part B says show that Z lies on the eclipse with the equation x cubed plus y 9 25 equals 1 over 4. That's what we want to prove, right? So it's not part about working out. So we want to show, because we want to relate it to x and y, right? X plus y, I equals, that should equal 5 to cos theta. Because we're separating into imaginary and not imaginary parts. 3 over 2 sine theta. I, yeah. Then eclipse with the equation. So we do want to separate the, because we can't make any equations with this, we have to use the equation cos squared plus sine squared equals 1. Right, so we'll first write x equals 5 over 2 cos theta, y equals 3 over 2 sine theta. Getting rid of the imaginary part, as we don't really need that. So then we can rearrange it. So cos theta equals 2 over 5x, and then sine theta equals 2 over 3y. And then because cos theta squared plus sine theta squared equals 1, 2 over 5x squared plus 2 over 3y squared equals 1. So that means 4 over 25x squared plus 4 over 9y squared equals 1. And then now to get it into this equation, we divide everything by 4. So that just equals to x over 25 plus y over 9 equals 1 over 4. And that equals to whatever they want us to find. So now we are up to part 3. So we need to show that z minus 2 plus z plus 2 is 5. Okay, so basically, as we figured out, z equals to this thing. So it'd be good if we copy it down because I can't remember numbers. So we're gonna copy it and drag here. Yeah, so z equals this, right? Oh, I accidentally missed the question. This is actually this is part 4, my bad. Let me move this down more. This should be D. User later. C. Coming back to C, they actually want us to show that z minus 2 equals 5 over 2 minus 2 cos theta squared. Okay, yeah. So as we, this just proves that all the questions are related. You should do them in the correct order, or it's gonna be very bad. Because from this equation, if we proved it, we know what z minus 2 is, and then we can do this question easier. So now we're going to continue doing this question. So basically, we just have to find out what z minus 2 actually is. So z minus 2 square root. Because square root, we put z minus 2 like underneath it, right? What z minus 2 is, and then we square each imaginary side. We have a square on the top, so we basically just have to do both the imaginary and complex parts. So first, we need this again. So z equals this thing, right? That means z minus 2 squared equals 5 over 2 cos theta plus 3 over 2 sine theta minus 2. And as we said, we just have to separate the imaginary and complex parts. Real and complex parts. So real is these two parts. So we just do 5 over 2 cos theta minus 2 squared plus 3 over 2i. Not I anymore because we're doing the magnitude kind of thing. Squared. And then the square and the square root cancel out, so it's just equals to this. And if it equals to this, we can expand out that z minus 2 equals 25 over 4 cos theta minus 10 cos theta plus 4 plus 9 over 4 sine theta squared. So that we can make sine theta equal something, not something like using the identity. So that just equals to 9 over 4 sine, it'll be 1 minus cos theta squared. So basically it's just let's take this because it's a minus sign. So that just equals 16 over 4. Oh, that's just 4. Yeah, 16 over 4. So it becomes 4 cos theta squared. Cos theta squared, take 10 cos theta squared. Theta, because that's not affected. And then we have to add this thing. So it'll be 16. So it'll be 20 plus 25 over 4. And we are still pretty far from the answer. So the answer still what? Because we found out what this is. We have to actually square. Actually, yeah. Yeah, actually, no, this literally equals the first thing. So what we have to do is just to simplify it because this is something squared, right? So it must just be cos it must just be two. It must just equal to whatever it says in the question. So it's just 5 over 2 minus 2 cos theta squared. Because we don't really know how to simplify this, but if we type everything, this square root is just equal to this, right? And then if we expand it, it's probably equal to that. So when the question says give me an answer, just give it in what you're doing, right? Now we're up to the last part. So basically we don't even need this anymore, yeah? Don't need this slide anymore, because that was, if we don't know what z plus, so we know this is just z minus 2 squared, so that means z minus 2 must just equal to 5 over 2 minus 2 cos theta, and then that means z plus 2, so the minus 10 would just be plus 10. Plus 10, this have to be plus as well, so it just becomes 5 over 2 plus 2 cos theta. And now we can make it so that z minus 2 plus z plus 2, that equals to 5 over 2 minus 2 cos theta plus 5 over 2 plus 2 cos theta, because there's a plus sign in the middle. It doesn't really change signs, so that just becomes 5 over 2 plus 5 over 2, because these two cancel out, and that just equals to 5, which proves the question. And that's it for the video. Alright, bye bye.